Welcome everybody from sunny San Antonio. Um, let's look at investigate particulate matter (PM). This website I'm showing to you is from the New York Times, and I can't get it from behind the firewall and share it with you. So how about you just explore this page with me, smashing that pause button a couple times. Particulate matter (PM). There's two different sizes. There's PM10 and PM2.5. PM10 is a big one. It's 10 microns across. PM2.5 is only 2.5 microns across. What's a micron? We'll pull out a hair, bink, and depending on the texture and size of your hair, about 4 PM10 particles can fit across a human hair. Four of those can go across a human hair. 16 PM2.5s can fit across that same hair. So it's much smaller. So you got your big. So what do we learn? There's two sizes of PMs of particulate matter. The PM10, the big boys, and PM2.5. Smash the pause button and answer this question: which of these sizes do you think is worse for your body, worse for human health? Smash the pause button. Unpause. PM2.5 is much more dangerous for human health. PM10, our bodies can trap that with mucus and cough it out. PM2.5, as we're about to see, can get down deep into the lungs and cause some serious damage. So this website's from a couple years ago, but it's still very relevant. Let's explore how San Antonio's air, when it comes to particulates, compares to some famous places. So this just shows me how am I like, okay, cool. This shows me what PM is. It's floating particles, PM2.5. And as you can see, each dot here represents a small PM2.5 particle floating in the air. In San Antonio, on our worst day in 2019, our worst was the air quality was at like 120 micrograms per cubic meter, which is unhealthy. If you go to when the campfire was happening in California, it was at over 100. It was 200 micrograms. You can see it's twice as much. Very unhealthy during those fires. You might remember like the sky was red, creepy, scary stuff. Let's go to New Delhi, India. Case study that we've studied a bunch already. Look at that difference. Extreme was New Delhi at 900 micrograms per cubic meter. Very unhealthy. And we saw that this is due a lot to not only city air pollution, but also to the cyclical pattern of farmers burning those crops to plant their rice when they do flood irrigation. So let's read real quick here. This fine pollution mainly comes from burning things. So what are the sources and impacts? This particulate matter, PM2.5, comes from coal power plants, gasoline in cars. So again, what are we thinking? Fossil fuels. We're thinking combustion. Um, but it also comes from woody materials, burning things. And then what are the impacts? PM2.5, the small ones, can evade our body's defenses, penetrating deep into the lungs and even entering the bloodstream, which is news to me. It has been shown to exacerbate asthma, lung disorders, increase heart attack and strokes. Is related to lung cancer. So because PM2.5 is so small, that's a type of air pollutant that we need to monitor because it's just associated with so much human health problems, issues. And so PM2.5 and PM10, those are both primary air pollutants, and we know the sources and impacts. One last thing to look at here. This is cool. This shows you that this particulate matter gets stirred up throughout the planet. Here's San Antonio versus San Francisco when the fires are happening. Real quick, check this out. Here is Delhi, India. Even on its good days, even on those days when there's not those uh, fires, agricultural fires, even on good days, it's just not healthy to be in New Delhi, especially when it comes to a PM 2.5. So I hope this was helpful. There's going to be some questions on this on your exam and probably on the AP test too. So that's it for me. And now let me stop this record. My recording will end in 27 seconds. Stop. Uh, mm, well, and then here's like this guy from UT. He's the one that's like really spearheading what's happening, um, and in New Delhi. If you want to go back up, how about? I mean, what the heck? We're here. Let's look at these. Let's look at this map. There's typical dust storms in China, and then other periodic events throughout the globe.